My name is Inigo Montoya. You killed my father. Prepare to die. God. All right, listen, everybody. Hello. I don't want to interrupt you with the makeup. Not that you need it.
It's the foil. My
Sure.
lips are dry.
Haley found a boyfriend at the beach.
You know what? Really?
I just want to hear his reaction.
I'm so happy. I'm amazed at you because Haley, she was part of the cadre that were trying to get this exam changed, and successfully, might I add, with the help of my supervisor,
Correct.
who I had to run it by.
Head of the table.
Yeah, head of the table, and I found that she's walking past every day this really great little sort of hole in the wall motel on Lauderdale Beach called Snoot. My wife and I. It's got a rooftop like bar, but like a patio sitting area. The bar was close. You can watch sunset on that and sunrise. Oh my God, we love it.
Is that in Lauderdale?
It's not. Yeah, it's Lauderdale, right on the beach.
Yeah.
I actually like Miami more than Lauderdale, to be
Oh
honest.
God, you're crazy.
Yeah, Lauderdale is nice.
Yeah, because it was like right by, like, you know, the Casablanca Cafe. Yeah, we like went to Casablanca, like Cabo Del Mar, which is like all on that. Like,
And there's so much. My buddy, and this will tell you how long ago this was. My friend, I might have shown you the picture, who I reconnected with after 34 years. He moved down there to live with his sister because his mom and dad had moved down there. And he used to go there at the clubs in Lauderdale. He's a great dancer. And there was a club called Ichabod's on that Gold Ocean Mile. And he would dance there, and all the girls looking for him were 6'4", skinny, the opposite of me, 5'8.5", generously and wide, Okay, sorry, he's taken.
Who?
He's my age, gonna be 72.
Oh. I don't think 72 is really my type, but
Never can tell.
okay. That's true.
Never can
He
tell.
could be my sugar daddy.
You must get in touch with my daughter.
Chelsea and your daughter could be besties.
Yeah. She want a sugar daddy? We could have the same one.
I don't think she's a sharer. I cannot be talking about this in class. I am apologizing to you guys out there in virtual
Why
world.
not? Who cares? They're not even
Where this is
listening.
politically incorrect.
I think Garrett.
It is politically incorrect.
Yeah, sugar daddy is not.
If you don't want a sugar daddy, you have issues.
Yeah.
In 2023, what's wrong?
Okay.
Times are changing, Dr.
In this
Stein.
economy?
Yeah, tell me times are.
In this economy,
I
Stein?
need like
Do you
Yeah,
see
all
how
the
much
babes are
it
going
is?
belly up.
Exactly.
I need to switch back to basketball.
Yeah, well, yeah.
You're done.
You missed
If
that.
you
TAFB. Let's take a break.
If you have any friends, you know who to hit up.
Just send him my email.
Send
Oh
them
my
a
God.
message.
Oh my God. I don't want to get fired after signing a new contract.
They bring up, they can't fire you.
Yeah, welcome back.
Oh, they can
You
fire.
guys should
Who's
bring it
gonna
up.
hire you, Badger?
No
No. It's
God.
Michelle
no
Badger?
between
Michelle Badger?
between who's ever in charge of the whoever the academic dean is.
Madam
overall.
President Michelle Patrick, if she fires you, I can tell you, I'll be the first one out there with like my picket sign and
Oh,
everything.
great.
Yeah.
Me too, I'll say Dr. Stein's supposed to
I-
be a sugar daddy.
I like Lou,
I like blue.
right? There's an old sign called I like Ike.
Stein, did you miss us?
Oh, yes. It's like
It's like having like 12 children.
yeah, 12,
How many is there?
21.
What?
It's like having 21 extra
the other
kids.
ones don't
Go-
really-
I always feel that way.
Yeah, let's be honest, do you really miss the other ones that aren't here?
Yes.
You're such a liar.
What are their names?
I miss everybody.
Yeah, what are their names?
Yeah, Alexa's on. There's 4 of them online. Here.
Yes, they're
They're talking trash, everybody.
They're not even listening.
These are trash talkers. I want you to see this. 4 others are. Look at this. Show everyone. Jenny, Janelle, Mackenzie, Sierra.
Hey.
It looks good.
Oh, really?
Alexa doesn't feel good. She got in touch with me. It's okay. I'm a reasonable person.
Seriously?
Yes. I am. Moving on. Ladies and gentlemen, mesdames et messieurs.
Can we skip the exam on Friday?
No.
Why?
All right, we're starting. We've killed 9 minutes and you're stuck with me for 2 hours this afternoon.
Yeah, but exactly. We're not
GTF over it.
What's GTF?
Get the.
Oh.
Sure.
Oh. That's a little aggressive.
Stop. All of you. T cells.
No.
Yes. We are doing T cells.
We learned this in immunology.
T cell, you're getting it again. Review never hurts. So the whole idea, it says it in the first word, cell. If a cell is altered, now we get to the MHC2s and the MHC1s and all that. And I'm not going to go crazy over it because you're fortunate that this term is the term that, because immunology is being offered and a lot of the students take it, I don't, the ones who aren't kind of get a break. Okay, so the idea is it's directly destroying cells and perhaps more importantly, the latter, chemicals that regulate the immunological. So it's more than just how the cell is programmed and how it attacks, and the variety of methods are fairly straightforward. The interesting part is all of the chemical intermediaries, which collectively you could classify as what are called ILs or interleukins. Okay, leukin because of their actions on other white blood cells and other members of the sort of the immunological front. It's very relevant, and it's relevant to me because I've had exposure. I take one medication that is part of that group, and I took another medication previously that was part of that group. So just working from there. So they're much more complicated. Okay, it's all about that marker, whether it's CD4 or CD8. All at that point we refer to them that way because they have not effectively been programmed. They are still would be categorized as both immature and naive at that point. So CD4s typically become helper T cells. They can activate with B cells, other T cells. That's the single most important cell in the immune system. It's the cell that produces most of the interleukins. And moreover, it's the cell that is tragically attacked by HIV. And that's where we really begin to learn a lot about. So other T cells, macrophages, et cetera, et cetera. And yes, in the old days, we used to call them suppressor cells. Now we call them regulatory. We used to look at the relationship between helper and suppressor cells. Now it's more about the absolute numbers of helper cells when we determine whether an immune system is collapsed, and obviously memory cells are part of it. CD8, cytotoxic, killer T, whatever you want to call them, T sub Cs, also memory. Okay, they're activated. Helper cytotoxic regulatory are activated T cells, the ones that are naive, as I said before. We just use the markers. The markers are important because not only they identify them, but like I said, it's an attachment point in the case of HIV, that CD4 marker. And they go through all this difference. We've seen this more or less before, which line it's going to go into and how they develop. Fine. Okay. The process fragments you already know about. The epitopes, the determinants, the antigens that are displayed on those MHC proteins. It's all about that. That has to activate the naive into the functioning one. And now you get into these two classes, class 1s versus class 2s. Okay. All cells except red blood cells, class 2s, displayed by antigen presenting cells, dendritic cells, macrophages, and B cells. So you have a variety or a mixture there. And again, that they're important because of what they're associated with. It effectively, for our purposes, if you think class 2, think helper. Okay, if you think class 2, you think of helper T cells and B cells. If you think of class 1s, you're really looking at more at the cytotoxics, to broad brush it. Okay, so endogenous self-antigens or non-self antigens are part of that sort of picture that's there. So the self part, the T cells recognize and don't react to, okay? And obviously, sort of the information, that's the whole idea of that T cell. Basically, it's all about what's being presented on those markers. The class 2 fragments are a little bit longer. They've typically been engulfed and broken down by an antigen presenting cells. They're recognized by the helper T cells, and basically that's their job. Okay? Help is required. See, and there's a good, hopefully the animation plays fairly well. As usual, I have to adjust the volume and hope it's activated. So different requirements, okay? CD4s, as you can see, once again, the class 2s, CD8s, the class 1s, okay? And effectively, that's what's it. The restriction is how to enable to be activated by non-endogenous phagocytized proteins, okay? And so what they're able to do, these dendritic cells have a way of getting around that. So the dendritic cells are all part of this antigen presenting cell group that are there. So now what happens? Two-step process. It's a little bit different than before. So you have to have binding and you need some kind of co-stimulator. That maybe is the nuance. And to me, the animation, hopefully it narrates here. If not, I'll make an effort to narrate. On the same surface of the antigen presenting cell, require for clonal selection. And you'll see they go through this. So the double recognition is important. That's part of it. Let's see if we get there. Co-stimulatory signals. Without that, energy, the term that they utilize, basically they don't become activated, whether they're tolerant, don't divide or morph into more, and don't secrete the chemicals that they're noted for. Okay, let's see. So, and just to go back time-wise, again, you see the response takes a certain finite amount of time. That's why the memory cell aspect is so significant for all of it. So it doesn't preclude the need for either treatment or antibiotics or anything along those lines during that, or that roughly, let's say, 7 to 10 day or 14-day period. Okay, the T cells undergo apoptosis, 7 to 30 days, and that's one of the problems. Okay, we need something to suppress their activity. That's one of the issues, and a lot of autoimmune aspects probably relate to inability to regulate that formation. And a lot of things can trigger it. So Stein anecdote 1. For the longest time, I always had osteoarthritis, wear and tear over time, complicated by a variety of other factors, maybe old injuries, maybe just a hereditary basis, because the side of the family that I basically take care of, my mom's side, it's always been arthritis. We live a long time, but we hurt a lot. And then I got bladder cancer. What they started to treat bladder cancer with is, once they discovered it and removed it, they put me on, interestingly enough, not the typical shotgun approach of using chemotherapy agents, but they used immunotherapy, which is much more progressive. You're trying to stimulate your immune system to fight, not only get rid of that cancer, but get rid of future cancers. So they instill, the term they use, it's called an installation. You can guess how it happens, mechanically speaking. Directly into your bladder. You can now guess how they get it in there. The direct method. That's why I have a very special relationship with Dr. Long. And they're not getting it.
No, I got
No,
it. That would hurt.
Chelsea got it, but
Did they sedate you or?
No, yeah.
Ooh.
No,
My one friend, remember, he had messed up kidney that they had to get fixed. So for that happened, they had to put a catheter.
yeah.
And they,
Ouch.
Yeah, and they said he had to do it away because they said they either knock him out and do it while during the surgery, or like an
Right.
extra however long, or they said you do it awake and it's a lot faster. So
It is a
you
lot
bit the
faster.
bullet, so.
So what I take is 5 milligram Valium before I visit.
Oh,
Valium.
Yeah, baby. That's what I'm talking about. La La Land, not the movie. And so what happened is they used, interestingly enough, it's called BCG. For you micro fans, listen to this. It is a bacteria. It's Mycobacterium bovis, which is like tuberculosis. Tuberculosis lives inside of cells. This bacteria similarly enters the cell, and in doing so, it activates your immune system. I'm giving it a short course. So it's the agent that is used for tuberculosis immunizations, which are not terribly effective, but they use a lot in other countries, particularly in India. So by stimulating my immune system, they most likely, not guaranteed, but if there was a tendency for me to develop an autoimmune kind of arthritis, this probably sends it over the ledge. So I'm in this. You want to stimulates your immune system to fight cancer, but you want to keep it quelled so you don't have an arthritic flare. I ended up with an arthritic flare. It's more common in people who carry a certain antigen. Another one of these certain antigens, another of these, they're called HLAs. Did you learn about those? Histocompatibility locus antigens. This one's known as HLA beta 27. It's been around for a long time, and it's been associated with cancers before. I was learning about it 47 years ago. Offhand. So, just a little sidebar. This is what happens. They show it to you here. Antigen is presented. Here's the dendritic cell, the class 2 marker. You can see the co-stimulatory molecule. They come together. So the CD4 cell recognizes the MHC. The co-stimulator also bonds and activates the process. And we generate helper T cells. The helper T cells, okay, once they're activated, so it's such an important part. And again, remember, this is the easier pathway. This is the MHC2 pathway, not the MHC1. Generates collectively we call cytokines. They're effectively all in the category of interleukins. For the longest time, we didn't have a lot of ways to treat certain conditions, but we could generate or make interleukins, though they were very harsh. So a lot of times in resistant cancer therapies, they give them courses, particularly of IL-2. Okay. Mediate cell development, differentiation responses. Interferons are generically part of it. There's a more specific one. Interleukin-1, released by macrophages to stimulate T cells, and their big player, that's sort of the general stimulator, is IL-2. Okay? It's the key factor that's there. Okay? It acts on that cell and other cells, so it's interesting that these chemical factors work both locally and more widespread, initiate division, amplify and regulate responses, okay, enhances the killing power of macrophages. That's, to me, the intricate part, and why we have a course dedicated to it, is the understanding of the complexity of this system. It is the most complex, I think, system that we have from a standpoint of, and we're really probably only scratching the surface. This is the laundry list. So lots of cells, alpha and beta interferons, antiviral effects, we heard about them. The gamma, activated macrophages, just talked about. Interleukins promote, these are pro-inflammatory agents. That's significant. Pyrogens, resetting the thermostat of the hypothalamus. Helper T cells, T and B cell proliferation, regulatory cell development, NK cells, because the NK cells are part, as you recall, of the innate immunity. So if something's activated your advanced immunity system, it's basically, look, if something got through that I have to respond to, you're not doing your job. So you need to bolster it. So they interchange, they interact, and more, and I'm not going to go through them. Here's the first one I'll tell you about that I had. Okay, secreted by Th17. I took an agent whose name is, it'll come to me, that is anti-interleukin 17. Okay, so interleukin 17 recruits neutrophils and it's a pro-inflammatory agent. It was fairly effective, but I had a lot of side effects that were associated with it, and I can't say that I responded that great. But there's a whole category, and as I recall the trade name, and I'll look it up, and just share it with you when we get over to the next part of the lecture program in the lab about what it was. It'll come to me. Okay. Suppressor factors in general, you can see that there's some of these that are part of it. These are interesting. Transforming growth factor, suppressor factor. IL-10 is probably the best known of the suppressor factors. You can have agents that try to stimulate that. You're playing this sort of tug of war between how do I stimulate and how do I suppress it so it doesn't overwhelm the individual. What I am taking now is this category. It's been around for quite a while. They're called tumor necrosis factor agents. They work against it. Okay, produced by lymphocytes, promotes inflammation, enhances phagocyte, chemotaxic, non-specific, slow tumor growth, etc., promotes cell death. So there are two. The first one that was around was intravenously administered, and they were using it for treating things like MS, called Remicade. I don't know what name, if that's still around or they use differently. The one that you've heard the most about that I basically take a variation is for the other tumor is by injection. You hear the term Enbrel because the golfer Phil Mickelson, typically for people with psoriatic arthritis or variants, which is kind of what I'm. So the one I'm taking is called Humira right now, and so it's like the pharmaceutical companies are printing money. A dose probably costs $5,000+. And other than my deductible, thank goodness for another reason why I'm going to work until I physically cannot, or I have another class like this, whichever comes first.
Come on.
That was just rude.
Because I can't take the excitement.
I'm just saying, if we didn't send you into retirement, I don't think anyone else will.
Yeah, no, it's all right. It's all right. Somebody else.
Next year you're gonna have boring kids.
Me. Is that a nice thing to say?
It's truthful. They're not us,
Who could be you?
Exactly.
So helper T cells, they help. Okay, they activate both arms. Once they're primed, they activate all the other guys. They secrete cytokines. Without them, your immune system collapses. That's the idea of basically what AIDS effectively becomes, and anything else that can produce that situation. They interact directly with B cells, displaying antigen fragments on MHC2 receptors. They stimulate other B cells, rapidly begin. B cells may be activated without the helper T cells, so some are independent, some are not. Okay, most are dependent. So they do play a pivotal role even in what you might consider just B cells alone. They amplify the response, if you want to look at it this way. This is the more complex. Now, this is the helper T cell, I beg your pardon, and the MHC2, and then the release of all of these chemicals. This is, to me, the more complex issue, the CD8. Okay, I can understand logically why that would be the case, because these are more destructive. So if they're misprogrammed and attacked, they're more likely to destroy healthy tissue. My thoughts on it. So again, become activated and destructive, cause dendritic cells to express co-stimulatory molecules, etc. So it's a complex process. You have attachment of helper T cells, you have co-stimulatory molecules, you have antigen presenting cells that are all involved. So it's a bigger part to get this effective. There's no easy way for you to accumulate this. Okay, what do? Amplifying responses of the innate system. Like I said, they're interchange, activating macrophages, mobilizing a variety of white blood cells. So there's a number of these. Okay, so as you can see, there's actually subsets of even helper T cells. Th1s, most aspects of cellular immunity. Th2, interesting. Parasitic worms, which are eukaryotic parasites. Eosinophils are the primary arm. If you remember what eosinophils do when those granules are released, they destroy like from the exterior and break apart things like worm from the outside, making them easy. And they also have allergies that are there. And so it's interesting that that's part of it. As I told you, my middle one had a diagnosis way back when he was little, like a year and a half, of eosinophilic gastroenteropathy. It was some type of allergic intolerance, which every so often he still demonstrates. And here's the Th17. That's the one they were trying to suppress with me. The difficulty is, plainly, I had a lot more side effects when I would take it. I take that injection at night. It's similar. It's like basically the same thing as EpiPen. Just pop it and snap it on your skin. Nothing to it. And I'd immediately lay down in bed, and I'd feel odd for a couple of hours. Very odd. I mean, one time I did that and came in here. I had such a bad headache. That was the start of last year's advanced phys in January. Like the first week we came back after winter break. Oh my God. Directly attack other cells. These are what we call them killer T cells. Circulate in the blood and lymph organs everywhere. It has to be a cell that's altered, whether a virus is inside it or a bacteria, some other parasitic cell. cancer cells, transfused or transplanted cells, the cell markers your body cannot accept. A lot of different ways they do it. A lot of times it's perforins, those little proteins that sort of poke holes in the cell and release granzymes that use those openings to stimulate apoptosis. Okay? That are there. And then they show you here's the perforins, here's the targeting, blah, 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 blah. It's actually what happens. They latch on. They're nasty. I was looking for that movie last night and it may be off of HBO Max. I suspect that maybe it's YouTubeable. That Fantastic Voyage. I mean, even though it's 60 years old, it was just fascinating to see what they thought about then with that. Okay, natural killer cells recognize other signs that killer T cells do not. If they don't have that protein, antibodies coating the target cell, different surface markers. It's sort of a similar mechanism. The NK cell is very much the analogous cell of the killer T cell, though not specified for a particular antigen. It's sort of the generic cell immunity cell in your innate system. Okay, so they're prowling around effectively, looking for different kinds of markers. It's not critical to me which markers one looks for or the other, but to understand their roles. The killer T cell, once it's activated, it will be all over. But in the absence of true activation, the NK cells fulfill that role generically. And of course, regulatory cells. So if we stimulate those in someone with an autoimmune or inflammatory disorder, theoretically, you could suppress that. So secreting inhibitory cytokines like IL-10, something called transforming growth factor, which is different, okay, than what I'm doing, the tumor necrosis factor, preventing autoimmune reactions, suppressing lymphocytes. Okay, so the question is whether or not this is something that they could look into vis-a-vis transplants are relatively new. For you folks, because of your age, the first time someone transplanted a heart was in the 60s in South Africa. Dr. Christian Barnard was sort of, and then transplanting, I mean, it was viewed strangely, as you might expect, like anything new. And, then we started to see this evolution of it. And again, much of it from here in Pittsburgh with the Starzl Institute, with larger organs. He was out in Denver doing liver transplants. They probably paid a slew of money to get them here. There's a lot to the backstories behind these, I'm sure. And then all this, you can look through the table as well as I. Let's see if this works. No guarantees. I guess let me see if the sound's on. Looks like it should be. Talk to me.
This patient's cold is caused by rhinoviruses, shown here in red, that entered her nasal passages and escaped the first-line innate defenses, such as mucus and cilia. Some of these rhinoviruses entered the respiratory epithelial cells, where they replicated, releasing more rhinoviruses into the patient's nasal passages and tissue fluids. In the tissue fluids, cells of the second line of innate defense, such as this dendritic cell, carry out surveillance for anything that appears foreign. Dendritic cells engulf the rhinovirus within an endosome. The endosome fuses with a lysosome, whose enzymes digest the rhinovirus. The resulting rhinovirus fragments are called epitopes. The dendritic cell then attaches the rhinovirus epitopes to presentation molecules called MHC2. This complex folds outward so that it sits on the outside of the dendritic cell membrane. The dendritic cell then enters a lymphatic vessel and travels to a nearby lymph node. Here, the dendritic cell, part of the innate defenses, encounters a helper T cell, which is part of the adaptive defenses. The T cell receptor or TCR, of this helper T cell recognizes the rhinovirus epitope, while the CD4 glycoprotein associated with the TCR recognizes the MHC2. The dendritic cell then stimulates activation of this helper T cell.
I love that.
Adaptive defenses help to control the current infection, but also provide immunity against future infections by the same rhinovirus. They are carried out by two types of lymphocytes, B cells and T cells.
It's odd that using rhinovirus.
Immature B cells
It's really
conduct
not a T cell.
surveillance in the lymph nodes, using B cell receptors, or BCR, to recognize only one specific epitope. The BCR on the left does not recognize the rhinovirus, but the BCR on the right does, and this B cell is selected for activation in a step called clonal selection. The selected B cell takes in the rhinovirus, degrades it, and presents the rhinovirus epitope with its MHC2. Our mature helper T cell recognizes the rhinovirus epitope with its TCR and the MHC2 with its CD4. Then the helper T cell secretes chemical messengers known as cytokines that activate the B cell. The B cell proliferates and differentiates in a process called clonal expansion, resulting in two types of cell. Memory B cells carry the memory of this pathogen for many years. Plasma cells secrete antibodies that conduct surveillance for more rhinoviruses, grouping them together so they are easy targets for phagocytes. Antibodies in the blood and tissue fluids seek out free rhinoviruses. The antibodies neutralize the rhinovirus by binding to its surface molecules, thus preventing attachment to host cells. Antibodies are humoral defenses that target free pathogens. But what about the rhinoviruses that are already inside our patient's cells?
Typically not,
Another
but they're
type of
using the
adaptive
example.
defense cell, called a cytotoxic T cell, can locate and destroy rhinovirus-infected cells. It provides cell-mediated or cellular immunity. Let's return to our patient's lymph node to see how cytotoxic T cells become activated. The T cell receptor, or TCR, of this particular cytotoxic T cell is genetically programmed to recognize the rhinovirus epitope when presented by the dendritic cell. This time, the epitope is presented differently, with an MHC1, which is recognized by a CD8 glycoprotein on the cytotoxic T cell. With the help of cytokines from a nearby helper T cell, the cytotoxic T cell is activated and clonal expansion occurs, resulting in some long-lasting memory cells ready for a subsequent exposure, and many active cytotoxic T cells, or CTLs, that leave the patient's lymph vessel to search for infected cells that present rhinovirus epitope with their MHC1. The epitope is recognized by the TCR of the cytotoxic T cell, and the MHC1 is recognized by the T cell's CD8 glycoprotein. The cytotoxic T cell then secretes perforin molecules, which form channels in the infected cell's membrane. Granzyme, also from the T cell, passes through the perforin channels and activates enzymes that lead to apoptosis, the programmed death of the infected cell. The cytotoxic T cell then moves on to look for another infected cell. Together, the humoral and cellular defenses are the body's third line of defense in fighting a very specific pathogen. The humoral defenses, ultimately in the form of antibodies, conduct surveillance for rhinoviruses that are outside the body cells, in the patient's tissue spaces and bloodstream. The cellular defenses, in the form of cytotoxic T cells, search for rhinovirus-infected cells inducing apoptosis when they are found. Memory T and B cells help our patient's body to recognize and more rapidly fight the same rhinovirus should it infect her again.
Okay. Fascinating. I mean, it's such a good summary. It really is. So when you read it step by step, it's complex. But basically, that's the whole idea of co-stimulation. They're very, very specific as to what they react to. I mean, again, I take issue with the idea. Rhinoviruses are generally on cells rather than in cells, but maybe there's some extraordinary types that are inside cells. I have to look that up. I mean, I've seen some pretty bad rhino. They're in that picoRNA category, like Kawasaki and Coxsackie viruses, which are nasty. You don't want them. Okay, but they're not that common. Which brings us to graphs. What are you doing?
What?
Oh God, most common. Okay, there's 4 different types of graphs. The allograph means same species but not you. Okay, same species. So the 4 levels you have autograft yourself. So if you think of typically when you do basically doing skin repairs where we're doing cosmetic procedures or treating burn patients, that's typically an autograft. Isograft if you have an identical twin. Allograft and it's most common for organs, certainly. And then lastly, the xeno for being not part of your species. And again, all the issues, all those MHC markers, this is the way you see that's tissue typing, ABO and other antigens. You have to use immunosuppressives. That's the problem. So it's a fine line that you walk. But years ago, you were looking at people lasting 3 to 5 years with a significant organ transplant. Now the amount of time is much larger. Okay, so all of these in the leading causes, you can see your best circumstance rejection after 10 years. So we call this 50% survival rate when this was written 10 years. Okay, that's desirable. I'm sure it's longer now because we have better quality immunosuppressants that are less likely to cause problems. Then we look at these deficiency-based states. This is more the diseases. I like to cover it. So you either have congenital or acquired that impair function of production. So this is the very, very famous, this is the old bubble boy syndrome that you probably have heard of. A very young John Travolta was in a movie with that. It was a very clever Seinfeld sketch. Where's George killing the bubble boy? That's my favorite line. You hear it all the time from Seinfeld, from the late Jerry Stiller. I got a lot of problems with you people, and you're going to hear about it. It's great line. Okay, so a genetic defect, deficits in B and T cells, particular enzyme, lethal to C cells. Now we have more available technologies like bone marrow transplants to treat these. Hodgkin's, much more common. Acquired deficiency, B cell line cancers, lymph nodes, immunodeficiency. I mean, you want somebody well known right around here? Mario Lemieux. Okay, is there an association with Hodgkin's? There's been an association. We used to look at Epstein-Barr virus as being a potential association with this. Now you classify these lymphomas as Hodgkin's and non-Hodgkin's. I don't know. I'm not up to date on the parameters. He was obviously treated very successfully. There was a history with regard to that. That was that very famous 93 season where they lost to the Avo people, the Islanders, in overtime in 7th game. What we like to call it, we in goal with a kid who was a goalie. When, you hold up your glove and it goes through, Barrasso. He did that on more than one occasion. His daughters escaped with my daughter many years ago. It was a first round pick, I think, of the Red Sox as a first baseman. Pretty good athlete. Acquired immune deficiency syndrome, AIDS, HIV virus, attacks the helper T cells. Effectively, it manifests itself like a cancer in the sense that your immune system can't function. You develop tumors, you develop multiple infections. There's the classic signs of what we call cachexia. CACHEXIA, are these. Night sweats, weight loss, like tuberculosis, same deal. Lymph nodes, opportunistic infections. The one that defined the disease was called pneumocystic pneumonia. Now it's got a different name, but it was PCP, stand for, it was a fungal infection. It's just not a fungal infection, it was common. And a physician out, and I've told the story, you probably heard it already, San Francisco, who identified this in gay men, because it had a large population. We saw the same thing in Philadelphia because it had the second proportion of, based on percentage of gay men in the United States. We were seeing this. I saw a cluster of Kaposi sarcoma, which is a very, very rare cancer that was around long before we heard about HIV/AIDS. Okay? So, but it was signs of this. Everybody knew in Philadelphia this was going around. These immune system collapse. I had lunch with a guy who I'm sure succumbed to that because you could just see the way he looked. It was awful. Because I must have told you, my first wife's, when we got engaged, she goes, my downstairs neighbor, okay, is gay. I just went, because he's a very handsome guy, roughly the same age, maybe a couple years older. And she used to be his date at the office Christmas party, at the awards dinner, because, society, you can only imagine what society was like with folks who would be shunned if they had come out and things like that. But that was his group of friends. So we know how it's transmitted. It's easily transmitted, blood and body fluids, all sorts of ways. It can go mother to fetus, helper T cell suppression, lymph nodes throughout, within. That's why it's categorized as slow. 2 to 10 years of untreated and it's not always that. It depends on the person's overall health and what we today call comorbidities. I don't know when Freddie Mercury was infected, but from his diagnosis, which is roughly 85, he succumbed in 6 years. But they were seeing Kaposi sarcoma as early as 1987. But he probably, based on his lifestyle, probably contracted it, let's say, late 70s or 1980-ish. Even though he was living with it, you see it in the movie, but it's a true story. They stayed close for forever. Yes.
So, it's what type of cancer is it of?
Pardon me?
So you said like a sarcoma. Right?
Sarcoma, connective tissue.
So what would it be like?
It was actually affecting blood vessels. It was affecting not the lining, but the intermediate layer of blood vessels. That's where sarcoma. So they're classified as that.
Oh, so they'd be internal. Okay.
It was very much internal, but it manifested itself in pigment and breakdown that appeared like malignant melanoma, which is a carcinoma, an epithelial cell. So we would see, and we were seeing. I can remember these cases like it was yesterday, back in 1976 and 77. It's scary. Seeing all those things. I remember John was the guy's name, and he goes, because they refer to each other with a feminine pronoun. Oh, she's got it. Whatever it was. Because they all had gals' names. And it was just, Charlton did the same thing with Freddie Mercury at the parties in his beautiful mansion inside of London. They all had different names. So then, it was a different culture that, we were more exposed culture to it now. Okay. So immune system collapses, dementia, there's characteristic MRI changes, etc. So they go through the laundry list of how it occurs. CD4 receptors, it's a reverse transcribing virus. What happens is that as the DNA effectively, not only does it destroy the cell, but a certain number of those cells become factories to basically clone into useless helper T cells, so the virus can reproduce. And again, there's an ample amount of treatment. The treatment is very successful, and then stopping the progression, we continue to have no options to treat it. We're now looking at integrase, which is how that provirus integrates with the host DNA. That's now part of the standard treatment. We're called integrase inhibitors. There's entry inhibitors. There's nothing preventative. And so far, it's sketchy. Every so often, we cured somebody of AIDS. We've not seen that long term to necessarily be true. And then let's stop it here, and I'll give you just a little spiel on these autoimmune diseases when we start lab. And then we're going into blood vessels, the dynamics of blood
So
vessels.
excited.
I contain your joy. I don't want you to, we can start at noon if you like. Dr.
No.
Buxton's not here for those who have.
Do we,
So
is
wait,
it in?
Yes,
lab? Is
yeah,
it
yeah,
there?
yeah. Not this lab, but
Environmental?
the comfortable.
so wait, you're lecturing in that, like,
You're gonna hear more of me for 2
for 2
hours.
hours? Like the whole 2 hours?
You're telling me. I gotta catch up. You're the one who wanted to test on Friday. You specifically.
2 hours.
I respect it.
I mean, it's fine.
Yeah, let's do it.
I'd rather have a 2-hour lecture than a test, so thank you.
Yeah, so yeah, exactly.
This is the price. This is the price you gotta pay.
That's fine.
Amen.
I'll deal with the consequences of my actions.
I made you an offer you couldn't refuse.
I thought we should
You did it. Your supervisor, let me tell you, your supervisor deserves it.
My supervisor knows how to negotiate.
Exactly. Let's put one in.
He's going to Camp Bow Wow.
He's at Camp Bauer today.
Oh, they're at Camp Bow Wow today. They deserve it.
He is having a good time at Bow Wow.
Oh, yeah.
I really look like that. I look like
Yes.
This is fun.
I'm pumped.
And you want to let
Huh? See,